This is Darshan Kochar on behalf of Team Kaju Katli. Today I am here presented by you to demonstrate my project GitGraphium. So first of all, I would like to tell you that how we have built this and what it does. So GitGraphium is an AI agent which tells you about the insights of any GitHub repository by just taking the input link of the repository, and it shows a dynamic graph representation and it gives you the real time updates about the repository. And for an unknowing question instance or any function which you are suspicious about, or you are not getting the specific code for the same, our project guides you to get the same. So here is a live presented demo with several repositories. Alright, it's loading, but the graph you can see in the background has been built using 3.js and GitHub's REST API. It visualizes the graph database. Although I have to tell you that this is a graph rack project, so we have used Neo4j as our graph database, and we are performing retrieval augment generation, and the pipeline has been built by us from scratch. It's just taking a while. So here we go. If I click on any one of this, you can see it's 3 dimension. All the nodes and repositories in capture. Let's try to ask something about the repository. So the repository I have been choosing is one of my hackathon submission for cybercrime classification. Here I have trained bird base and case. So whatever it is, right now I just have given the repository link, and I am asking a very simple question that how we are performing sampling in this repository. So here we go. The output says that the provided function resample data is used to perform sampling on a given data set to ensure the class distribution. Here's a breakdown of how sampling is performed. So here we go. Oh yes, all the front end you have been seeing is has made by one of my friend Tejas, Keshwani, and Priyadarshi as well. Both of them has helped me throughout this project, and together we have built this. So this has been built over Next.js, and the graph you are seeing right now has been built on 3.js. Alright, for the LLM which we are using for the processing is Llama 3, and it's not just this repository, we can go with any other repository as well, although the responses you can see are very much similar and fetched. For the verification of the same, I want to show you this. Trying to make it more easier for you, the function must be present there. Alright, you can see that here is the resample data function which tells us about the upsample, oversample thresholds as well as the subcategories which we are using currently right now. And when you look at the explanation, it gives us very clear and very fantastic output. You can see the counts as well as the default values, parameters. I mean, if this is with me, I can code anything and everything, I guess. Such a clear understanding is what I have got. Now, more than this, we should try something else. Okay, he is one of my senior, Mr. Aryan Bagel. I also want to give a shout out to him for his idea. I'll write any of the repository we can choose. Let's choose what he has made in Google Hackathon. Here we go again. While it's taking a while, I should give you a demonstration of the code. So this is not what I was talking about. This is the one which I was talking about. So here is the backend build. The APIs were built with fast API, but yes, you can see from the scratch. I mean, for the code explanation, I have been using Neo4j as one of my graph databases. Oh, no, not this one. Just toggle it on the version. So yeah, when it comes to the building, first we are cloning the repository. Oh, clear database is just one of the function which is helpful. Then we are pre-processing. While we are pre-processing, we are storing the nodes as the root, and then we are using os.walk, a given very helpful library in Python for the overall evaluation. So here we are just going on inside the repository, parsing repositories, and then storing the file nodes as name and establishing the relationships between the nodes and the edges and the other nodes, naming them. Then we are parsing a Python functions here. It's extracting Python functions here. Generally, we are using Python, but it works well with the JavaScript as well. We can change the parsers, so it can work with any kind of function: C, C++, .js, .typescript, .solidity, any kind of file, any kind of functions. It should not cause any such error. While we are ignoring the configuration files like git config, git attributes, and others, here we go down, and yeah, we are storing the metadata as well as the storage data. I can show you. This helps the traversal over the repository very fast. Once we cross that phase, we just go down, and then what I'm telling you is what we are doing. So we stored the functions in the Neo4j database. Then we just recall that to generate image captions. Okay, so we are storing image captions, and not just image captions, we are storing natural language descriptions of the functions which we have parsed, and after storing them, we are using cosine similarity, and we are using which model? Okay, this is the sentence transformers all mini LLM v2. For this, using this, we are computing the similarity scores, and after calculating the similarity scores, we are performing similarity search. Based on a similarity search, we are just giving the given output. So these are the two routes I have created, and we are simply performing these actions here. Clear repository database, because Neo4j comes with a free rate limit. Then after we are cloning, then pre-processing, and then after storing that, we are fetching functions, generating descriptions, generating embeddings, storing back in Neo4j while we are calling the chat function. I'm showing you, this is my chat function. We are having memory, buffer, responses, as well as some other things present. So this calls our similar process query function, and process query function, if gets some of these keywords, it just call our tool. So this is our agent, and this agent is calling the tool, which is the similarity search. Not just similarity search, the whole pipeline is built over that. Then we are finding the best embedding, and if we are not finding one, it's working simply. Now after that, if if the query is not regarding the chatbot, then it should just answer this questions simply. Okay, maybe we should just, now I'm supposed to run it again in front of you. The back end is closed right now. Same goes with front end. Here we go again. Okay, peace. It should work right now. I'm sure. So here we here again we come. This is the repository of Aryan Kumar Pakhil sir. So yeah, what I was saying that the front end has been built over Next.js. If you wanna see this, I can show this to you. I'm extremely thankful to two of my teammates, Priyadarshi and Tejas, while we have built this together. All right, it comes with some of the features like light mode as well, and yeah, we can just get this to a full screen once it's done. We're using everything open source, so like yeah. The chat bot is supposed to stop until we just clone this repository properly. Maybe the repository is too long, so it's taking a little bit longer. It's supposed to work right now. So let's just get back to the code, and if you want me to show you the front end, then this is what we have built. These are all our files. I mean, I would say just go to this repository and check all of it if you're looking to check my project. This is the backend. The documentation has been clearly stated and specified how it works. While if you're curious about checking the front end, this is what we are talking about. It's very simple. You just have to clone it, npm install and npm run def. I hope you won't get any trouble doing this. So again, this is what I was talking about. This is what it makes me very helpful. So let me ask any anonymous questions about it. Although it's not my own repository, but just to show you how it works with others as well. For now, let's just close the graph. Just because I have some insights about the code, I am able to ask the right questions, but you can see the response, the quality of response it's generating. and it can clearly be verified with the help of that. So here is me, Darshan Koche, presenting my project in front of you. Thank you for your time.